Good morning.
Good morning, ma'am.
Good morning, ma'am.
Morning, ma'am.
We'll continue the yesterday class. So there I have told you that sometimes the modern power plant they will utilize the combination of the reheat and regenerative cycle. So reheat means there suppose we will have the high vaporization pressure. So why we are requiring high vaporization pressure? The reason is that to achieve the maximum mean temperature where we can add the heat to get the maximum work specific work output from the plant. But by using that reheat alone, the problem is the decrease of the thermal efficiency. So in that case, thermal efficiency will be less. So reheat means there we are using the two turbine. One is the high pressure turbine and low pressure turbine. The expansion will achieve in these two turbine. So in between these two turbine, we are reheating the steam, which is done by the reheater. So that pressure is almost very much high. So that pressure will be in between these two. If you are observing, this is the TS block. So in between these two, this is the reheat pressure. So why we are doing this? We are doing this to get the maximum mean temperature of heat addition, um, which will have the increase a certain uh, amount of utilize a certain amount of heat so that the efficiency will not be so much less as compared to the simple Rankine cycle. So that is your reheat cycle. Then we are also combine the regenerative cycle in this case. So why we are combining the regenerative cycle? The reason is that some amount of heat, suppose we are adding in the feed water and it is going to the boiler. So whatever amount of fuel is utilized in the furnace, so that will be reduced to get that maximum temperature of the steam. So like that we can reduce the fuel consumption and we can increase the thermal efficiency. So thermal efficiency will depend upon the heat input also. So in that case, that heat input in the form of the fuel combustion product that will be reduced. So by using little amount of steam from the turbine and increase the temperature of the feed water, we can reduce the fuel consumption. In that way, we can increase that thermal efficiency of the plant. So that's why we have used these reheat and regenerative cycle cycle in combination. So here we have used the three heater. One is the heater 1, heater 2 and heater 3. Most of the power plant they will use up to the 2 heater. The reason is that there will be the increased cost of the reheating pipe. So it will increase the plant cost. So for that reason, so maximum people can use up to the 2 heater or 2 to 3 heaters, so not more than that one. It will increase the plant cost. Okay. So here it is a modern steam power plant. Here we have used the reheat cycle and regenerative cycle where we have used 3 heater and 2 turbine. Okay. So if I'm going to explain this schematic diagram, you can see it is the boiler. From boiler, we will get the, let us consider 1 kg of steam. So that 1 kg of steam is entering to the high pressure turbine. So their expansion will be done up to the pressure 3.3. So in between there, I have here we have used the steam, which is that steam is run at the point 2. So that steam will be utilized at the heater 1. And the end of the expansion process, so that point 3, there the amount of mass, suppose the at point 2 m1 kg of steam is drawn, then at from 2 to 3, that expansion will be, that amount of mass will be 1 minus m1 kg of steam. So that expansion will achieve in this 2 to 3. So here it is the 2 to 3 if you are observing. So here it is the uh, 1 minus m1 kg of mass is expanded up to the point 3. Then what we are doing, we are reheating that steam in case of the reheater. Then it will go to the low pressure turbine. Okay, so 3 to 4 is the process of the reheating. So if you are observing, it is the 3 and this one is the 4. So 3 to 4 is the process of reheating. So here the reheating will be achieved up to the maximum cycle temperature, T max. Okay. So here it is the T1 is equal to T4. So in this case, the amount of mass is 1 minus M1. So that will be entered to the low pressure turbine. Then there will be expansion of the steam from 4 to 5. That steam amount is 1 minus m1 kg of steam. Then suppose at the point 5, we have drawn m2 kg of steam to increase the temperature of the feed water, that is used in the heater 2. Here it is the heater 2. So here we have used m2 kg of steam drawn from the low pressure turbine at the point 5. Okay. Then there will be again expansion from the point 5 to 6. So here it is the point 5 to point 6. So in this case, the amount of steam will be how much? That is 1 minus m1 minus m2 kg. Okay. So previously it was 1 minus m1, then we have drawn m2 kg. So that amount of steam will be 1 minus m1 minus m2. Okay. Then again what we are doing at the point 6, suppose we are again drawing certain amount of steam, that is the m3 kg of steam is drawn at the point 6 and that is utilized in the heater 3 to heat the feed water. Okay, so in this case, the again there will be the expansion process, from that will be the point 6 to point 7. So during the expansion process, the steam utilization is how much? 1 minus m1 minus m2 minus m3. Okay, so this amount of steam will be expanded from the point 6 to 7. So it is the point of condenser entry. So it is the condenser where your steam will lose the heat. So heat rejection will be there, and that will be formed to the condensate. So that condensate will be become the saturated liquid at the point 8. So it is the point 8. Then we have used the pump, that is the 8 to 9. So it is the pump to increase the pressure of the feed water up to the pressure. This line feed water heater. So up to the heater pressure. So this is the heater pressure. So it is the inlet to the heater 3, and this point is point 6 is the inlet to the heater 3. Then again it will go to the pump 2. So the amount of mass will be how much? That will be the 1 minus m1 minus m2 kg. Okay. So here it will be become 1 minus m1 minus m2. So this point, and it will go to again the point 10 to 11. This will be entry to the heater 2. Okay. Sorry, 10 to 11 is the pump 2. So this is 10 to 11 pump 2. Then we are using the heater, that is the 11 to 12. So here the heat exchange process will be there. So how much amount of heat is released in this case? Steam is used that will be used to heat this feed water. So here the mass will be how much at this point at the heater 2. So in this case the amount of mass will be 1 minus m1 kg. So again, that will be pumped by the help of the pump 3 to the heater 1. So that point is your pumping point is your point 12 to point 3. Okay, sorry, point 13. So it will go to the heater 1. So here that will be heat exchange process. Temperature will increase 13 to 14. So then that uh, that feed water temperature will increase, as well as in this case the amount of mass of feed water will be about 1 kg. Okay, so here it is the 1 kg. Then it will pump to with the help of the pump, that is the pump 4. So for 14 to 15. Then there will be the heat addition from this 15 to 1. So like this, the reheat and regenerative cycle will continue. So three heater are used. Two turbines are used for the expansion process. So I think now it is clear to you for the schematic diagram, and this is also clear. This is the TS plot, how how this is plotted. Okay, so now we will write the turbine work output for this one, and then we have to write what is the pump work output. Then we have to find out what is the Q1 and Q2. Q1 means heat addition and heat rejection. So let me first write down what that energy balance equation for this heater 1, heater 2, heater 3, so that we can get the amount of M1 kg and M2 kg and M3 kg. So how much amount of M1 is drawn, M2 is drawn, and M3 is drawn, that we can get. So okay, so let me write down the energy balance equation for heater 1. Okay, so for the heater 1 means this is the heater 1. So the inlet point is your 2. So in this case, the amount of mass is M1. Then enthalpy will be the H2. Okay. So it is the M1 into H2, which is entering to the heater. So here it is the inlet section. So what is the mass at this case? Any one of you, can you tell me what will be the mass at this case, which is entering to the heater 1? Please,
1 minus M1
1 minus M1 into what will be the enthalpy at the
into H13.
H13. Very good. First, okay. So in this case, the amount will be the M1 H2 plus it is sorry 1 minus M1 multiplied with H13. Okay, so this is input to the heater. Then output is how much? It is the क्या होगा?
H14
H
H14.
14.
into
Okay,
1.
1 to 1 H14. So from here we can get the what is the M1. Okay. So similarly for the if you are doing the energy balance equation, so what will be the equation in this case? So this is the heater 2. The entry point is the point 0.5. Okay. So amount is M2. So it will be the M2 into H5. And this point, it is point 12. This
1
is entry
minus
is
M1.
12. Okay. Entry 12. Okay. No. I think it is the 12. No. Okay.
Yes,
Ma'am,
ma'am.
entry depth.
Outlet is 12, inlet is 11. Okay. It is the 11 and outlet is 12. So how much it will be? The mass will be?
1
1
minus
minus
M1
M1
minus M2.
minus
1
M2.
minus M1 minus M2.
Okay. So the I can write as M2 H5 plus entry is H11. No, entry is H11 at this point and outlet is H3. At this point it is the heater, so H12 is outlet. So it will be the 1 minus M1 minus M2 multiplied with H11 is equal to your, here in this case it will be the 1 minus uh, M1. At this point M2 ऐड हो गया, M2 ऐड होने से ये 1 आउटलेट हो जाएगा 1 minus M1. Okay, so it will be H12. Okay, so from this equation we can get the M2. What is the M2? Okay, so similarly for the heater, shall I write this one or you will write it? Better you can write it. Okay, energy balance equation for heater 3. Okay, so for the heater 3 means it is 13 and 14 section. Okay, feed water heating is your 13 and 14. तो यहाँ पे entry point is 6, so that will be the M3 is 6, and in this case the amount of mass is 1 minus M1 minus M2 and M3 multiplied with H9, and it is your how much 1 minus, यहाँ पे mass कितना होगा H10.
1 minus M1 minus
1
M2.
minus M1 minus M2.
Okay, so this will be M3 H6 plus 1 minus M1 minus M2 minus M3 H9 is equal to your 1 minus M1 minus M2 into H10. So from this equation or relation, we can evaluate what is the M1, what is the M2, and what is the M3. Okay. So similarly, we can write our turbine work output. So turbine work output will be how much? So in this case, expansion is at the 1 to 2 point, then expansion is at the 2 to 3 point, and then there will be the expansion 4 to 5, 5 to 6, and 6 to 7. So in case of the 1 to 2, what will be the mass in this case? So in this case, there will be the 1 kg. Okay. So 1 into H1 minus H2. So then we will have the 2 to 3 point. So 2 to 3 point means in this case, amount of mass will be how much?
1 minus M1.
1 minus M1. 1 minus M1 multiplied with H2 minus H3. So in this case, 4 to 5, it is the entry to the entry point to the low pressure turbine. So here there will be expansion, that is 4 to 5. So in this case, the mass will be how much? That is 1 minus M1 multiplied with H4 minus H5, right? Then there will be the expansion in case of the 5 to 6 process. So in this case, the amount of mass is 1 minus M1 minus M2. So similarly in this case, that will be 6 to 7. Okay. So let me take this diagram to the another slide. So in this case, WT will be how much? 1 into H1 minus H2 plus, and that will be 1 minus M1 H2 minus H3 plus here it will be 1 minus m1 multiplied with h4 minus h5, and then there will be the expansion 5 to 6. So in this case, the mass will be 1 minus m1 minus m2. Enthalpy change will be h5 minus h6 plus, then there will be the expansion process in case of the 6 to 7. So here the mass will be 1 minus m1 minus m2 minus m3. The enthalpy change is H6 minus H7. Okay, so this is the turbine work. So how to evaluate all these point? So suppose the pressure is given at this point. So you can get the what will be the H2, okay, H14. So in this case, the reheat pressure is given or reheat temperature is given. So according to that one, you have to find out saturation pressure. Then you can find out what will be the value of H3. Okay. So similarly at this line, and you can find out H5 and H12 at the particular pressure. Okay. So like that, you can find the values of the enthalpy. Also, you can find out the entropy. So here it is the entropy. Okay. So then we will have the pressure pump work. So the pump work is WP. So pumping is done 8 to 9 process, 10 to 11 process, 12 to 13 process, and 14 to 15 process. Okay. So first one is the 8 to 9 process. So 8 to 9 process means in this case mass is used how much?
1 minus m1 minus
1
m2.
minus m1 minus m2 minus m.
Okay. Obviously then Rama, right? Okay. Then can you tell me what is the mass in case of the H11 and H10? H11 यहाँ से 10 to 11 में यहाँ पे कितना मास?
1 minus m1
1
minus
minus
m2.
m1 minus m2.
Okay. So we can write down that one. The mass is 1. First, in case of the process 8 to 9, the mass is 1 minus m1 minus m2 minus m3. The enthalpy change is your H9 minus H8. So similarly, here the pump 2, that is the 10 to 11. In this case, the mass will be 1 minus m1 minus m2. The enthalpy change is how much? The enthalpy change is your H11 minus H10. H11 minus H10. So similarly, in case of the pump 3, so 12 to 13. In this case, the mass is 1 minus m1 and enthalpy change is H13 minus H12. And then we will have the pump 4. So that process is 14 to 15. So in this case, that will be 1 into the enthalpy change is H15 minus H14. Okay, so this is the pump one. So similarly, we can get the heat addition. So can anyone tell me what will be the heat addition in this case?
H1 minus H15.
Yes, ma'am.
Okay,
H1 minus h50.
Yes, ma'am.
H1 minus H15, right? Or any other thing? एक ही जगह में हीट
कहने
एडिशन हो
से
रही है
बताता हूँ
हाँ
नो
नहीं
मैम, अभी
ऑडियो
हीटर से
का
हीट
ऑडियो का
एक्सचेंज हो रहा है.
ओके आपका डायग्राम
Ma'am, h1 minus h8 plus h4 minus s3 plus continue.
राइट यहाँ पे आपका रीहीट हो रही है ना रीहीटर में तो रीहीटिंग प्रोसेस कहाँ पे है
9
0.3
to 10.
टू 0.4 है ना ये प्रोसेस में आपका स्टीम पे से रीहीट हो रही है हीट एडिशन हो रही है ना गॉट माय पॉइंट
यस
यहाँ
मैम
पे सो ये पोर्शन में भी हीट ऐड हो रही है ये पोर्शन में भी हीट ऐड हो रही है Q1 Q supplied and in this case Q supplied. Okay, so the mass will be how much at this point at this process? 3 to 4.
1 minus m1.
1
1
minus
minus
m1.
1 minus
m1.
m1.
1 minus m1. Right. So it will be the heat addition will be in case of the boiler, that is the H1 minus H15. Then it is in case of the reheater. Reheater में mass is 1 minus m1 and enthalpy change is your H4 minus H3. So this is your heat addition. The unit is your kilojoule per kg. So here all the unit is kilojoule per kg. Okay, kilojoule per kg. Then we are having the heat rejection. So heat rejection is how much?
H7 minus H8.
Okay.
H7 minus
So heat rejection is at the amount of mass is how much? 1 minus m1
M1
minus
minus M2 minus
m2
M3.
minus m3 H7 minus H8, right? So this is the heat rejection. So then you can find out what is the thermal efficiency. Okay, and what is the net work output. Okay, what is the steam rate. So you are having the formula. You can find out all these values: thermal efficiency, network output, steam rate. Okay. So this is all about your reheat and regenerative cycle. So in this case, we are using the open heaters. So let me discuss the type of heaters used in case of the uh, regenerative cycle. This is known as the feed water heaters also. Okay, so there are two types of heaters can be used. One is your open heater and another one is the closed heaters. So whatever we have discussed till now, so that is all about your open heaters. So in case of the open heaters, that is also known as direct contact type of heater. In this case, whatever the steam will be drawn from the turbine, that will be allowed to mix with the feed water. So that when it is mixed with the water, what will happen? That steam will be form into the condensate, and that feed water temperature will increase. So both that condensate and feed water, that will be mixed together, and that will leave from the heater at the common temperature. So if you are observing in this case, so both will be leave at the common temperature, and that will be pumped to the another heater. Okay, or it may be pumped to the directly to the boiler pressure. So that is the open type or direct contact type of heaters. So there is another heater is your closed heater. So in case of the closed heater, the steam and feed water both will be not in contact. So this is also known as the non-contact type of heater. So in this case, the feed water will flow through the tubes, and outside of the tubes, that the extracted steam will be flow, and that feed water will take the heat from that extracted steam. Okay, and the temperature will increase. So by taking the temperature of the steam, that feed water will leave from the heat exchanger. So that I can say one type of heat exchanger. So that will go to the boiler. Okay, that steam which is losing heat to the feed water, that will be formed into the condensate, and that condensate will be collected at the outer cell. Okay, so sometimes that cell is also known as the collector or that is known as the heater. That collector is connected to the heater drip. So sometimes that drip, when we will open that water, the trapped water or condensate water, that will be removed from that cell. Okay, so this is the close contact type of heater. So mainly people are using open heaters, so that there will be no complexities. So that can be used directly to the uh, boiler. Okay. So this is about your heaters. So last class, someone has asked me that, ma'am, is it the one type of heat exchanger? No, open heaters is not a heat exchanger, but closed heater is the one kind of heat exchanger. I think it is clear now. Okay. So next one is your certain drawbacks of this water. So in steam power plant, what we are using the water as the working fluid, right? So that will work as a two-phase system. First one, it will be the liquid phase, then it will be the vapor phase, right? So, but that working fluid, the water will have certain drawback. So that's why in sometimes we are using the binary vapor cycle. Okay. So what is the name? The binary vapor cycle. Binary vapor cycle means here we are using the two working fluid. So because of the certain drawback of the water as the working fluid, we are using the two fluid so that our that cycle temperature will increase. So already I have told you, if we are increasing the cycle temperature of plant cycle temperature, so in that case, what will happen? It will be restricted to the material condition which we are using, and the pressure condition, the maximum pressure will be limited. So that is also restricted to the metallurgical condition. So generally, if we are discussing the modern plant, there we can use the maximum temperature of 600. Okay. So in that case, your critical temperature of water is how much? That is about I think 375 degrees Celsius. Okay. So we cannot go beyond that temperature. Okay. So let me explain it before the binary cycle. So let me explain what is the ideal characteristics. So there are certain ideal characteristics of the certain characteristics of the ideal working fluid in the vapor cycle. So as we are using the water as the working fluid in the power cycle, so it cannot go beyond that the maximum temperature that can be used in the steam cycle. So generally, the whatever material, available material, the best material used in case of the steam cycle is that temperature, maximum temperature it can sustain up to the 600 degree Celsius. But your critical temperature of the steam is your 375 degree Celsius. Okay. So suppose we want to increase the temperature, the steam temperature. So in that case, you have to use the superheating process, and that is the one point. So superheating means there you can include the number of tubes, so which will also increase the cost of the plant. And another thing is that it will not allow allow the maximum temperature of heat addition, as it is having the critical temperature is 375 degree Celsius. So we cannot add much more heat. Um, so in this case, at this high temperature, so we cannot go up to this temperature. Okay, so this is one drawback. Another thing is that in case of the suppose steam is the working fluid, so in that case, suppose we are going beyond the increase of the steam pressure, so that we can get the maximum mean temperature where we can add the heat. So if we are going beyond a certain high pressure, so in that case what will happen, so it will have certain moisture content. So high moisture content will involve when we are going beyond the high steam pressure in order to obtain the mean temperature of the heat addition. So in that case, reheater are used to obtain that high pressure. So if we are using the reheater, so as I have already told you, the reheater tubes are costly. Okay, so we cannot use more than the three heaters. So we can use
Class is over. Everyone can leave now.
पक्का ना?
कौन था ये?
नवनीत।
सुधर जाओ चंदू।
क्या एपिक आवाज में बोला है?
नवनीत गा ही दो।
एक परफॉर्मेंस नवनीत का।
क्लास खत्म ना, चलो।
नहीं हुआ।
भाई गा दे।
भाई नवनीत
कंटिन्यू
55 लोग है लाइव।
भाई गा दे।
50 नहीं।
यूट्यूब पर आ जाएगा तुम।
भाई गा दे।
गा दे नवनीत, कैमरा ऑन कर।
भाई गा दे।
गा दे नवनीत।
चंदू टैलेंट दिखाओ अपना।
तुम
भाई गाओ नहीं
नाचेगा।
तो शेखर गाने लगेगा, फिर कंप्लीट कर देगा।
वही कंप्लीट कर देगा।
गाना फिर रितिका परफॉर्म भी करी।
वो देखो नीतीश कैमरा भी दिखा रहा है।
कहाँ है ये कल?
भाई दीपू यहाँ भाई
ऐसे कौन
पढ़ते हैं,
लाए?
मजाक है
पुलिस
क्या?
कैंप है, ट्रेनिंग कैंप।
तो तुम वहाँ क्या कर रहा है?
लो नारियल पी लो। लो नारियल पी लो।
बजरंग दल का ट्रेनिंग कैंप देखे।
ये बाबू गिर जाएगा ना, बस सारा नारियल सूट जाएगा।
ओके गाइस।
आई डोंट थिंक मैम अब आएगी। वो कॉल नहीं उठा रही है, वो मैसेज नहीं सीन कर रही है, एंड टाइम भी हो चुका है।
टाइम नहीं हुआ, 45 तक टाइम।
अच्छा 5 मिनट और वेट कर लो, वेट करो, लीव मत करो।
तुम परफॉर्म कर दो तब तक।
चंदू है
पहले बोलना
क्या?
चाहिए था, 50% अटेंडेंस पहले गायब हो चुका है।
अरे तू डाल देंगे नोटिस, सब आ जाएगा।
रितिका नोट्स बनाती हो तुम?
ये भी करना होता है क्या?
और आज रजत पूछ रहा था हमसे, भाई हम भी सोच रहे थे कि शायद लड़की लोग बनाती हो।
बस भाई नितेश, बस
नीतीश बस समझ गया सब। इतना घुमा फिरा के नहीं बोल रहा है।
रितिका से बात
शरीफ
करना है तो
लड़कियां
डायरेक्ट
बनाते
बोलो,
हैं।
रितिका तुमसे बात करना, मेरे को क्या फंसा रहा है।
हाँ रजत।
मैम अच्छा नहीं पढ़ा था, मैम नहीं है ना अभी, बच्चे नहीं उनका।
तुम ट्यूशन जाती है ना?
अच्छा
ट्यूशन
नहीं।
अबे साढ़े
इंजीनियरिंग
10 बजे
क्लासेस।
नया एपिसोड आने वाला
मैम
था,
अच्छा
वही
नहीं
देखना
पढ़ाती
चल
है ना?
रही होगी ना। चलो चलते हैं, बाय बाय गाइस।
भाई पढ़
ये
ले
बाय
भाई,
बाय।
कहाँ जाना है?
अभी कैंसिल का नोटिस नहीं आया है, अटेंडेंस एट योर ओन रिस्क।
छोड़ना।
तू गा ना।
करतब दिखा ना।
मार देंगे तुमको, गला कहीं का। म्यूट करो इसको।
बस दीपू बस।
क्या हुआ भाई?
क्या
क्या
कर रहा है
करते क्या तुम बार बार क्यों डकार मार रही?
देख तेरा डकार के कारण और अटेंडेंस कम हो गया है।
वही रितिका
बिल्कुल अटेंडेंस कम नहीं होगी। हो गया आप लोगों का?
यस।
वेरी गुड। यही होता है आप लोगों की। ओके, आप रितिका मुझे अटेंडेंस दे दीजिए। नवनीत और शेखर सुमन, क्लास के बाद जो करना है करना, मेरे कान तक जैसे ये सब बात ना आए, ठीक है? ओके, थैंक यू ऑल।
थैंक यू मैम।
थैंक यू।